Okay, so in this second lecture what we're going to do is do a little bit of extra work on arrays, paying particular attention to two-dimensional arrays, and then we're going to do an extra little bit on how to deal with the string data type. So, in the last lesson, when we created an array, what we found was that the array was actually empty, and then we had to write additional code afterwards in order to put the values into the array. We don't have to do it that way. What we can do is, if we know what the values in the array are going to be, we can actually create the array with a preset number of values in it. So we're going to do it by going back to the window cleaner example, and we're going to expand on that a little bit. What's going to happen is that we've got an array, and we're going to basically clean the windows in the building according to how dirty the window is. So we're going to use an array to represent the windows in the building, and then each window or array element will store an integer value which will represent how much dirt is actually on the window, or how dirty the window is. And the more dirt on the window, the higher the number that's going to be in the array, and that'll define how many times we have to wipe the window in order to make it clean. So what we'll do is we'll start with something relatively simple, and with something that we already know, and we'll look at just one floor of a building. So as you can see, this is one floor of a building, and what we've done is we've got 5 elements in the array: 0, 1, 2, 3 and 4. And what we're going to do is we're going to initialize the array as part of the program with pre-defined amounts of dirt on each window. Now, we already have covered the code to be able to do that. So if you have a look, we've got a variable declaration to tell us that it's an array, and we've then initialized that to set it up for 5 elements, and then we've done single declarations or lines of code to basically put the values in each of the elements of the array from 0, 1, 2, 3 and 4. For our example, that's perfectly fine, but if you can imagine that we had a much larger array, we would have to have lots of these lines of code, and we can obviously almost probably do it in a better way. So what you can do is you can set up an initial array with a square brackets and an array name. But what we can do is we can set up the initial values in curly brackets after the declaration, and we split each of the values up with a comma. So in the case of this, what we've got is an array declaration with the arrays preset in. So that's index 0, 1, 2, 3 and 4. We don't need to create any code to basically initialize the array in the constructor, which you'll see in a minute, but we also don't need to write the code to actually use user.inputInt to actually type the values in. So let's think about the class that we're going to write in order to initialize that. We've got a dirty windows class with an instance variable called window dirt, which will be the array which will store the amount of dirt on each window. We're going to count the number of wipes that it will take to clean each window. We've got a method called display dirt, which will show us the amount of dirt on a particular window, and that's going to take a parameter which will tell us which array index we want to display. We've got wipe window, which will allow us to reduce the amount of dirt on the window by 1. So 1 wipe is one element of clean, so it will actually reduce the amount of dirt by 1, but it will increase the number of wipes that's actually been performed altogether. And then display wipes will tell us the total number of wipes that it's actually taken us to actually clean all the windows. So let's have a look at that now. Okay, so I've downloaded the Dirty Windows application from the VLE. I've opened it up in BlueJ, and we'll just give it a quick compile, make sure everything's alright. And let's have a look at the code for it. What we've got is the Dirty Windows class. We've declared a constant num_win for the number of windows, and we've set that to 5. And obviously that'll go 0, 1, 2, 3, 4. We've defined the array for the amount of dirt on the windows in each of the elements of the array. I've called it window dirt of an integer data type, and then we've got the 5 values 2, 1, 0, 2, 3 in indexes 0, 1, 2, 3, 4, and we've got an integer variable to tell us, or to add up the number of wipes that we take to clean the windows on this particular floor. In the constructor, we initialize total wipes to 0. In the display dirt method, we have a parameter pWinNumber, which is an integer, and it will display the amount of dirt on any particular window that we pass into it. So for example, let's say 0, 1, 2, 3, which is that one. We pass the value of 3 into there, and it'll tell us that the dirt on window 3 is the value of window dirt at position 3, which is the value of 2. In wipe window, again, we tell it which window we want to wipe. So in this particular case, let's pass 3 in again, so pWinNum equal to 3. If the value of pWinNum at position in the array, so that's position 3, if it's greater than 0, then we will knock the value of the amount of dirt at that position down by 1 and add 1 onto the value of total wipes. I'll show you how we do that when we run it. If it's not greater than 0, it must be equal to 0, in which case it's pointless cleaning a window that's already clean. And in the display wipes, we just output how many wipes we've actually performed in total. So let's give that a compile, and let's create an instance and inspect. And what we'll do is we'll do this in context of one array index, and we'll just do it in context of 3. So we can actually see how the array changes when we call all the methods. So in the first instance, let's just display dirt, and let's have a look at the dirt at index 3, and it tells us that the dirt on window 3 is 2, which is right, and currently the total number of wipes is 0, which again is correct because it tells us up here. So let's wipe window 3 once, and straight away it knocks the amount of dirt on the window down by 1. If we wipe that window again, it knocks the amount of dirt on the window down by 1 again, and if we wipe that window again, it should tell us that the window is already clean because we've got no dirt on it. Okay, so as a development from that, we're now going to look at the concept of a two-dimensional array, and the best way to represent two-dimensional arrays is to think of it as a table of data like you would in a spreadsheet. So for example, in our Dirty Windows example, we're going to basically have the ability to clean the windows on multiple floors rather than on a single floor. And basically what we've got are rows and columns of data, and we're going to use that method to, for example, clean all the windows on a block of flats with multiple floors. So we can represent a two-dimensional array a little bit like this. And as you can see, we've got 4 floors, each floor containing 5 windows. Underneath each of the windows, we've actually got the representation of row number and column number. So the one in the bottom far left corner, the first number is the row, the second number is the column or the window number. So this one will be row 0, window 0. So one along would be row 0 because we're in the same row, row 0, window 1, row 0, window 2, row 0, window 3, and row 0, window 4. Likewise, along the top, we're on floor 3. So it's floor 3, window 0, and for example, row 3, window 3. So creating a two-dimensional array isn't that much different to creating a one-dimensional array, but we just need to make sure that we deal with the rows as well as the columns. So when we declare the array, we need 2 sets of square brackets to tell Java that we're dealing with 2 dimensions. And then when we create the array itself with the size, we actually need to put the value of rows and columns in the square brackets. Or, by what we've seen already, when we declare and initialize the array in one go, we can actually do it by creating the rows and columns of data. The only thing that's a bit weird when you do it this way is that you have to remember that you're almost creating the array upside down. I know that sounds a bit daft, but if you think of it this way, this is row 0, so this is 0, 0, 0, 1, 0, 2, and this is 1, 1, 1, 0, sorry, 1, 1, 1, 2, in context of the row numbers here. So 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2. A lot of people think of it as an array of arrays. I don't think of it like that. I basically think of it as rows and columns of data using sort of XY coordinates as if you were playing battleships or something like that. So, to access each of the elements of a 2D array, you need 2 sets of square brackets. The first one contains the row, and the second one contains the index of the item in that row, or the column, or in our example it's the window number. Remembering that array indexes always start from 0, so if you wanted to access, for example, the 4th item in the second row, it would be 1, 3, because you would have 0 as the first row, 1 would be the second row, and the fourth item will be 0, 1, 2, 3. Okay? All you got to remember is the first row would always be the row or the floor. The second one will always be the column. So, what we need to do is try and think of a way that we can actually process each of the elements of a block of flats. So we've got a block with 4 floors, 0, 1, 2, 3, and each floor has got 5 windows in it, going from 0 through to 4. Okay, let's have a look at it. Okay, so I've downloaded the Dirty Windows 2 program from the VLE, and we'll just give it a quick compile and we'll just examine the code. Okay, so we're dealing with a 4-story block of flats, and as you can see, we've got a constant which we've left at 5 for the number of windows on a floor, and then we've declared a 2-dimensional array. Now remember, back to the slide that we saw before, row 0, row 1, row 2 and row 3 and then in each of those we've got the windows 0, 1, 2, 3, 4. Okay, so 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, and on this one 1, 1, 1, 2, 1, 0, start again, 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, and moving on from there. We initialize total wipes to 0 in the constructor, and we've changed the display dirt method to incorporate the floor number and now the window number, because we need what floor we want to show the dirt on and what window number on that floor we want to display. We've modified the user.message to say the dirt on window, window number of floor, floor number is the value in the array of floor number, window number. Likewise for the wipe window, we've now added another parameter for floor number and window number. If the amount of dirt in that particular window is greater than 0, we knock one off the amount of dirt on that particular window and add one onto the number of wipes. If the amount of dirt is greater than 0, is not greater than 0, then the window's already clean. And display wipes hasn't altered, that just tells us how many times we've wiped a window. Now, when we're dealing with two-dimensional arrays in BlueJ, sometimes it can get a bit messy. So what I'm going to try and do is lay things out so that you can see things a little bit more clearly. So I'm going to move this over here and I'm going to create a new instance and I'm going to inspect it. Now we're dealing with a two-dimensional array, so if I double click this now, you can see that we've got row 0, 1, 2 and 3, but each one has values inside it. It's got 5 values inside it. So what I'm going to try and do is lay it all out so that when we call the methods we can see it a lot more clearly. So that's row 0, that's row 1, that's row 2, and that's row 3. And I'm going to have a lot of trouble getting all this to fit into a single window, so I'm just going to move it there. So ground floor, first floor, second floor, third floor, and I'll leave that there because it's all represented in there. So what I'm going to do is first of all show that the number of wipes is 0, which it is. And what I'm going to do is I'm going to target a particular window on a particular floor. So I'm going to hit, let's have a look, let's hit the 5th window on floor 3, which is this one. Okay, so we've got floor 0, 1, 2 and 3, and I'm going to hit the 5th window along the row. So what I'm going to do is I'm going to show the dirt or display the dirt on floor 3, window 4. Now if I've got this right, it should come up with the value of 3, which it does. So I'm going to clean that window. So I'm going to call white window, and I want to call the window on floor 3, window 4. So this should drop down by 1, which it does. I'll do it again. Floor 3, window 4, drops to 1, and once more, floor 3, window 4, goes to 0, and if I attempt to wipe it again, it should tell us that that window is already clean, which we already know. And just to double check, because the original amount of dirt that was on that window was of a value of 3 and we've wiped 3 times, it should tell us that the total number of wipes is 3, which it is, which tallies up with the total wipes in there. So, when we originally dealt with single dimensional arrays and we wanted to visit each of the elements in that array, we used a loop. In fact, we used a for loop in order to visit each of the elements. And we went from index 0 to the last one, and that loop allowed us to visit each of the elements one by one. If we've got a two-dimensional array, we can use the same methodology. But what we have to do is think of a way of visiting each of the elements in the array, or each of the windows in a building, which is what we're leading to, in a structured manner. And the way that we do that is we use something called a nested loop. Now, a nested loop is basically a loop inside a loop. So again, we're going to look at the block of flats as an example. And what we're going to do is we're going to move from floor to floor, and then as we visit each floor, we're going to go from window to window within that floor and repeat it. So if you think about how we're going to look at that, if we've got a two-dimensional array, let's have a look at a very simplified version. Let's say it represents our building. We already know that we've got 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 1, 2, 0, sorry, 2, 1, 2, 2. So we need to be able to hit each of these in succession. So if you think about that, we've got 0, 1, 2, and 0, 1, 2. And what we need to be able to do is hit each of those in succession. So 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2. So the outer loop that we're going to use in this nested loop will go from floor to floor. So the outer loop will cover this, and the inner loop will go this way. And that will allow us to visit each of the elements, or each of the windows on each of the floors in each of our buildings. So if you visualize the visitation of each window, we start on floor 0 and go to windows 0, 1, 2, 3, 4. Then we go up a floor and visit windows 0, 1, 2, 3, 4. Go to floor 2 and visit windows 0, 1, 2, 3, 4. And then go to floor 3 and visit windows 0, 1, 2, 3, 4. Then what we're going to do is output a message for each window. Now, if you think about having maybe a 10 by 10 block of flats and the use of the user.message, you can imagine if we had one message for each one, it would just take absolutely ages. You'd be forever clicking the OK button. So what we're going to do is, as part of this, we're going to learn how to create a string data type, which will basically build our message up of all the windows along a single floor. And then we're going to basically add the amount of dirt on the end of each string, and then we can output that string. So we literally get one message for each floor, but that one message will output all the dirt. So we're going to use strings. You've probably used strings before in other programming languages, but strings can help us put sort of letters, numbers, characters on the keyboard, even things like tabs and carriage returns we can use. And you probably have already used them, like I mentioned, but we're going to use a data type called a string, and it's going to help us to build our strings to represent the dirt on each of the floors in all the windows. Declaring strings in Java is pretty straightforward. It's about as straightforward as any other language. The term that we use is string, capital S, and the name of the string. Anything that you want to incorporate into a string, you put in double quotes. and you can use the plus sign as a concatenator for different strings. So for example, in this example, I put my name equals Paul in quote marks, and then I concatenate it with another string with a space and my surname. So when we output that, when we put my name and that string together and put it in my full name as a string, it will just output that as one. So very similar to a lot of other programming languages that you've used. Concatenation is used with the plus sign, but the additional bit that we can incorporate is that we can use the plus equals operator. Now, it's a shorthand method. You might have seen it in other languages or in other lectures where maybe you deal with let's say you're dealing with numbers, and you'll say x equals x plus 1, which will get the value of x, add 1 to it, and put it back into x. Now we know the shorthand for that, that's x plus plus, and we're sort of used to using that now. But we can let Java add values onto add string values onto other values with the use of something called plus equals. Now, plus equals is very much like x equals x plus 1, but with strings what it will do is it will actually join them together. So we can say, for example, in this example, let the value of message equal Paul. So initially the value of message is Paul. Then we say message plus equals a space. So what then we've got is the value of message with a space concatenated onto the end of it. So we've got a space that's added on. And then in the third line we've said let message equal message plus my surname, and that's added on to the end there. We can also do that with lots of different data types. So let's say we've got a string and an integer. We can use that along with strings. So let's say we've got floor number, which has the value of 7 in it. We can concatenate strings and integers, and it treats them all like strings. In fact, Java converts it into a string for us, which isn't that particularly easy. In some languages you have to convert them, so it actually saves us a lot of time with that. So what we're going to do is we're going to write a new method called display all, and that method is going to go through all the floors and all the windows of our building, and it's going to build a string of all the dirt on all the windows on one floor. And once we've gone through all the windows, it will output that value and then move on to the next floor and process that floor until we reach the top. So let's have a look at that. Okay, so I've downloaded the program Dirty Windows 3 from the VLE. I've given it a quick compile, and let's just open it up in the editor just to see what it is we're dealing with. So a lot of the elements for Window Cleaner 2 are still in there, so I don't need to go through those. I'll only just go through the changes. But first thing is we've now got two constants, one for the number of windows on a particular floor and one for the number of floors in our building. We've got our two-dimensional array set up with all the dirt in it. So don't forget floor 0, floor 1, floor 2, floor 3 for all four floors, and we're still adding up the total number of wipes. We initialize total wipes to 0. Display dirt doesn't change. We put the floor number and the window number in, and it tells us how much dirt's on the window. Our wipe window hasn't altered. Floor number and window number again. If it's greater than 0, we knock one off the value of the dirt and add 1 onto the number of wipes. If the amount of dirt on the window is 0, it's already clean. And display wipes just again tells us how many wipes we've made for our particular building. This is the new one. This is the first example of using a nested loop. So we'll go through this quite carefully. When we call display all, we have two integer variables for the current floor and the current window, and they're going to be used inside our outer loop and our inner loop, and then a string declaration for MSG or message, which is going to output each of the values. So let's worry about the outer loop, which is this for loop. Now this is dealing with the floor that we're visiting. So we go from current floor 0 and keep going as long as current floor is less than the number of floors. Now the number of floors was declared as a constant, which was 4. So as long as current floor is 0, 1, 2 or 3, it will then increment current floor by 1 every time the loop comes round. So that's the outer loop. For each time we go around this loop, we generate the initial startup message, which is the value of floor, or the word floor, with the value of current floor added onto it with a colon. Then we hit the inner loop, which is this for loop, which goes from current window equals 0, and that will go as long as current window is less than num windows. Now if you look at that, num windows is 5, so that's perfectly fine going round as long as current window is 0, 1, 2, 3 or 4, and then current window again gets incremented by 1. Now, not even taking into account the value of MSG, which is just basically just putting the message together for the output, current floor will hit this loop with a value of 0, and then that stays, the floor number stays at 0 and then goes through the current window. So if you think about how that works, it'll be 0, 1, 0, 0, 0, 1, 0, 2, 0, 3, 0, 4. It comes out of this loop and goes back. Current floor then changes to 1, so that'll be 1, 0, 1, 1, 1, 2, 1, 3. Again, go round, current floor changes to 2, 2, 0, 1, 2, 3, and then it should exit the loop because we've visited all the floors. Taking the message into account, we start off with the startup message, like I said, with floor and the current floor, and then we add the value of the dirt at the value of floor and window in the array with a space on the end of it. So what we're doing is saying floor, for example, 0, and then the value of the dirt at window 1, window 0, 1, 2, 3 and 4. Once we've done all that, we then output the whole message, which will be the value of the floor and all the dirt on every window. So, but again, best way to demonstrate it is by running it. So what we'll do is we'll show you the status of the array again. We'll move some windows around so we've got some room. And then let's try and stack this up so we can see what's going on. So floor 0, floor 1, floor 2, and it'll have to go to one side because I haven't got the room, floor 3. And what I'm going to do is basically go through the entire loop to show you how it outputs all the data. All the others will still work in that we can, for example, let's wipe the window on floor 0, window 3, just to keep it clean. So let's wipe window floor 0, window 3, and we can see that that's changed to a 0. So all that works in exactly the same way, but it's the display all method which allows us to cycle through. So let's just keep an eye on how this works in context with all the strings that we're generating with the two loops. So we call it, first time round, it says floor 0, which it is, 32200, 32200. Go on to the next floor, 21303, floor 1, 21303. Floor 2, which is there, 03130. And then floor 3, which is there, 21023. So what we've done is we've just used some basic string handling to join together the values out of the array to basically allow us to see the status of the array and doing it floor by floor rather than doing it window by window, which means I'll be hitting the OK button quite a lot. Okay, so everything that we've learned so far we can now apply to the latest incarnation of the window cleaner class, which is window cleaner 5. We're going to basically use a two-dimensional array to store the amount of dirt on each window. The only sort of difference is that the ground floor hasn't got any windows, so all the first row will be zeros, and the leftmost window space for each floor, i.e. window 0 on each floor, is being used by the cradle lift. So each of the elements in that will be 0 as well. But the rest of the array represents all the dirt on all the windows. So it looks a little bit like that. Everything on floor 0 is empty, and everything on window 0 on every floor is 0, so that it represents where the cradle moves up and down. So what we've got is something a little bit like that. Remember, it's an upside down representation, so that's floor 0, floor 1, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, floor 2, and floor 3. So, what we're going to do now is we're going to introduce a new charging plan. So, Wendy will now charge the base charge for cleaning the window, the height surcharge, which was always in there anyway, which is the floor factor multiplied by the floor number, but there will also now be a cost per wipe. So the dirtier the window, the more you pay. And what we're going to do is introduce these instance variables as parameters to the constructor. So we set the prices when we first start everything up. So the wipe window method is now going to be expanded a little bit to include a while loop to process the wiping of the window. So as long as it's still dirty, wipe it. And every time we go round, we reduce the number of wipes on the window and we increase the charge. So every time we wipe, we get more money. So we need to store the current window number, which is going to be used in a variable called mCurrentWinNum. And we already have go up and go down methods for moving up and down the building, but we now need methods for going right and going left. And when we clean the windows, we're now going to have to introduce our nested while loop to move right along each floor and call in wipe window for each window. And then that helps us to basically automate the cleaning process. When we get to the far right, then we've got the ability to sort of move left and go back into the cradle. So let's have a very quick overview of how that works. Okay, I've downloaded Window Cleaner 5 from the VLE in the lesson folder for this lecture, and as we always do, let's have a look at the code first. It's not my intention to go through all of it because obviously there are lots of elements where things haven't changed, but I'll give you plenty of time to sort of examine the code yourself in more detail. I'm just going to summarise the changes that are made based on the new learning that we've made. So, we've got the Window Cleaner 5 class. We've got a predefined building in this particular example. So the top floor is 3 for 0, 1, 2, 3 because there's technically 4 floors. And then there's 5 windows on each floor going 0, 1, 2, 3. We've got floor, and that obviously maintains what floor we're on. We've got window number for what window we're currently on. We've got the base charge, which is the standard charge for each window. We've got the floor factor, which is the multiplier depending on how high up we are, and the total charge for the total cost, plus the cost of a per wipe. Gate open was the check to make sure we don't go up and down without closing the gate. Here's our two-dimensional array, much the same as the one in the PowerPoint slide. So floor note has got nothing in it, and window note on every floor is 0 because that represents the cradle. Now just be mindful of that, because we'll adjust our loops to accommodate that, and I'll bring that to your attention in a minute. First thing is our constructor, probably the most complex constructor we've seen, but it takes 3 parameters: an integer for the basic charge, the multiplier for the floor factor, and the cost per wipe. And we set those values to base charge, floor factor, and wipe charge in the constructor. We initialize current floor, current window, and total charge to 0 because we haven't done anything to a building yet, and the gate is open for the cradle. Go up doesn't alter, go down doesn't alter, but we've now introduced go right and go left. Go right will add 1 onto the current window number to go from window 0 to 1 to 2 to 3. Go left means that we knock 1 off the current window number to go from 4 to 3 to 2 to 1. And when we wipe a window, we have a local variable for charge, and what we do is we have a string initially empty called wipes, and you'll see what happens with that when we run it through. But the cost of a window will be the base charge for a window. We add on the multiplier of whatever floor we're on multiplied by the floor factor multiplier. The higher up you are, more danger money you pay, the more you get charged. And what happens is that will go into the charge. While in this loop, the amount of dirt on the window at that floor, that window, is greater than 0, we add the word wipe onto our string called wipes. So we're basically having a string which builds up according to how much dirt's on the window. We then reduce the amount of dirt on the window by 1, and then add a charge for that wipe, and we go round this while loop as long as there is still dirt on the window. After we've cleaned the window, it will then report that it's cleaned the window on that floor and add the charge for that window onto our total charge. Bill and reset is exactly the same. It tells how much it costs. Open the gate. That hasn't altered at all, apart from bill and reset, which it uses for basically outputting the bill, but bill and reset is called there. Close the gate. Closes the gate. And then this is the main one. This is the main method which we do for cleaning all of the windows in this building. So what we do is we deal it on this main loop. So while the current floor is less than the top floor, so while we're not on the top floor, we call go up once and then loop round from window to window. So while the current window number is less than the row number, so while it's less than, in the case of this building, the row number is 4, so we'll go 0, 1, 2, 3. So while it's less than 4, we move right and clean that window, and then we'll go to the next window and clean that one, and go to the next window and clean that one until we reach the final one. Then we get to the end of the row. We've got to move back along it. So while the current window is greater than 0, so while we're over here on 4, we go left, 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 left until we reach current window 0, and we'll keep doing that. We're going from floor to floor in this bit, window to window in this bit, eventually cleaning everything, and then we go down from the top to the bottom, and then we open the gate. So hopefully we can see how that works. And again, I'll try and represent this by creating an instance. So we'll charge, I don't know, base charge 50p with a flow factor of 5 and 2p a wipe. Okay, so we've actually got now our building. There's a lot of variables that we can look at. We'll leave that there. And let's examine the array as it changes. So again, ground floor, first floor, second floor, and third floor. And what we'll do is we will call the method to clean the windows, and there's 2 bits on there, so we're cleaning window 1 on floor 1. Okay, now it should have already sort of set that out. So the dirt on there was 2, so there were 2 wipes that had to be made, so that's the string concatenation bit. Notice we'll have a look at it on this one as well. Two lots of dirt on that one, 3 lots of dirt on that one, 1 lot of dirt on that one. Then we go window 1 on floor 2, window 2 on floor 2, that's got no dirt on it. Window 3 on floor 2, window 4 on floor 2, and then we just go through all the windows, basically eliminating all the dirt on each one, with a final bill of £7.60. And you should find that all the dirt on all the windows has been eliminated. Okay, just to summarise then, it's been a bit of a trek this lecture, but the concept of 2-dimensional arrays is something that you really need to get hold of when you're learning programming. Basically representing tables of data using 2-dimensional arrays, accessing them by a row number and column number, making sure that you always remember that arrays 1-dimensional and 2-dimensional are indexed from 0. We've looked at the use of nested loops to access all the individual elements of a 2-dimensional array, and we've applied that now to cleaning all the windows of a building using a 2-dimensional array to represent the dirt on each of the windows. And then we've had a very quick look at the string data type, which we now can use to store textual data, and how we've used the plus equals logical operator to basically lump bits of strings together or concatenate strings together. And we are going to look at strings in some of the later lessons to do some more complex things.